Welcome to the important question practice session on the Laplace transforms. Okay, combining different areas and different important types of question from the Laplace transform. Let us get started one by one. Okay, so yeah, before we start up, important update that is on the BYJU'S Exam Prep. Sunday, it's 2 days later, 12th May at 12:30 p.m. Rakesh Sir, the dashing M.Tech from IIT Roorkee and more than 5 years of experience, is going to take a detailed strategy session, a free mega workshop that is going to be very important. Attend this on the app, and he's going to talk about how to secure a rank under 100 in the GATE 2024. How to secure the rank under 100 in GATE 2024, right? Join live, register now for free. And also guys, Sunday on the same YouTube channel where you are watching this session, straight at 11 a.m. in the morning this time, I bring to you another important guidance session where I'm going to talk about 5 important success mantras, okay, to secure a single digit rank, which is a dream for all the aspirants, a single digit rank, a top rank in the GATE examination, right? The steps 1, 2, 3, 4, 5 that can lead you eventually towards your victory in the GATE 2024 or 2025 examination, right? Chalo guys, let us get started with some fundamental and some good questions. We'll keep a mixture of both. Okay, the idea is to cover a broad variety of questions that can be expected in an exam like GATE from the Laplace transform. Okay, so always question practice sessions play a key role. Let's have a look into this one. If UT RT denote the unit step and unit ramp functions respectively, and UT convolution RT is their convolution, okay, then the function UT plus 1 convolution RT minus 2. Now it might appear that it is a convolution based question. But is it actually a convolution based question? So if you go and solve the convolution of step with ramp by the integral, by the convolution integral, it's of course going to be lengthy. What you can do here is, you can take the help of the Laplace transform. You can here take up the help of Laplace transform, because we fundamentally know that for the step signal, Laplace transform is 1 by s. Okay. And for the ramp signal, the Laplace transform is 1 by s square. We know that basics. So what should be the Laplace transform for ut plus 1? So we can apply the time shift property, u of t plus 1 to e raised to the power plus s divided by s. Okay, time shift corresponds to the exponential term. What should be the Laplace transform for r of t minus 2? The Laplace transform for rt minus 2 would correspond to again time shift t minus 2. So it should be e power minus 2s and then divided by s square. And then divided by s square, isn't it? Okay, so now if I talk about ut plus 1 convolution with r of t minus 2, now there is a convolution between two time domain signals, and convolution in time would correspond to multiplication in the Laplace domain. So what is going to be the Laplace transform correspondingly? That is going to be multiplication of e power s by s into e power minus 2s divided by s square. So your answer would be e raised to the power minus 3s upon s cube. But answer is the answer of convolution, sir. Right, we have the answer of convolution that is going to be in time domain only, but by using Laplace we have ended up in a result in the s domain. So if this is the result in the s domain, whose Laplace transform it could be? So again, okay, it is s cube. So think where s cube will come. S cube will come in the t square ut case. Okay, what is the Laplace transform for t square ut? As we know, for t power n ut it is factorial n. So here it is going to be factorial 2 divided by s power n plus 1, so s power 3. Okay, s power 3. So 2 factorial is 2, we can divide on the left side. So 1 by 2 t square ut will have the Laplace transform 1 by s cube. So at least I have got to the 1 upon s cube. What I need to take here is the e power minus 3s term. And how does the exponential term comes? When we have a time shifting. When we have the time shifting. And I need e raised to the power minus 3s. Oh, I'm sorry, it is e raised to the power minus s. A small typo error. It is e power minus s plus s and minus 2s, e power minus s. So I need e power minus s, and that can come by t minus 1, the time shifting corresponding to t minus 1. So let us do the time shifting here. Half of t minus 1 whole square, u of t minus 1 would have the Laplace transform e power minus s is divided by s cube. E power minus s is divided by s cube. Half of t minus 1 whole square ut minus 1. Half of t minus 1 whole square ut minus 1. Option number C. Option number C. Straight moving ahead to the right. Half of t. Yeah. Moving ahead to the next question. Okay. So I'm taking a GATE question also, periodically in between. Okay, for good understanding of the level. So what is that? Let the Laplace transform of a function ft which exists for t greater than 0 be f1s and the Laplace transform of its delayed version be ft minus tau. Of its delayed version ft minus tau be f2s. For ft it is f1s, for ft minus tau it is f2s. Let f1 star s be the complex conjugate of f1s, okay, with the Laplace variable as sigma plus j omega that we already know, right? Yes, iconic C is the correct for the previous one. Okay, if gs is equal to f2s into f1 conjugate s divided by modulus of f1 square s, does it look like a complicated question? Okay, let's have a look into this. So ft has the Laplace transform of fs. Now I am discussing about f2t. Now what is the f2t? Yeah, it's delayed version ft minus tau. Okay, yeah, f1s tha, I think, correct? For ft minus tau, actually you think what is the Laplace transform as per the Laplace properties? It is going to be f1s, again the exponential term e power minus s tau. f1s e power minus s tau, correct? And this is equal to f2s. This is equal to f2s. This is equal to the f2s. Okay, the f1s e power minus s tau is equal to the f2s. Is equal to what? Is equal to the f2s, correct? Is equal to the f2s. Okay. Now let us come to this function. Okay, let us come to the gs function. What is gs? It is given as f2s, put it as f2s into f1 conjugate s divided by modulus of f1 s whole square. Now let us put down and then understand whether it is a complicated or an easygoing question only. Okay, so f2s, what is f2s? It is f1s e power minus s tau, right? Whole multiplied by f1 star s divided by modulus of f1s whole square. Divided by the modulus of f1s whole square, right? f1 into f1 conjugate. Now guys, for any complex number, what is z into z conjugate? Z is given by x plus jy, so z conjugate is x minus jy, and when you multiply you get x square minus a square minus b square, but j square will be minus 1, so eventually it is x square plus y square. It is a very commonly known property for a complex number. Now x square plus y square ka under root is mod z, so x square plus y square is mod z square, and it is a very commonly known property that z into z star is mod z ka whole square. Same thing you can apply here. f1 into f1 star is coming. f1 into f1 star is coming, so that will become like mod z square, it will become mod f1 s square into e power minus s tau divided by mod of f1s ka whole square. Okay, so modulus of f1 whole square got cancelled. Okay, and I am getting the result. This is known as gs. So the gs is equal to e power minus s tau, which can be written as 1 into e power minus s tau. Okay, what is the inverse Laplace transform of gs? That means I want to calculate gt. Okay, so that means what is the gt? I have written e power minus s tau as 1 into e power minus s tau. Suppose I hide this, there is no e power minus s tau. Then the Laplace transform is 1. And 1 is the Laplace transform for unit step or unit impulse. 1 is the Laplace transform for unit impulse. But it is e power, it is having that exponential term, and that exponential terms comes because of the time shifting case, so it should be delta t minus tau, the unit impulse shifted signal. Okay, so the answer should be an ideal impulse that is delayed delta t minus tau, and the correct answer here is gonna be option number B. The correct answer is B. Right, everybody? The correct answer is an ideal delayed impulse delta t minus tau. It is a delta t minus tau. Done hai ji. Let's move ahead then. If this is done, let's move ahead. Chalo. Let xt be a signal. Let xt be a signal that has rational Laplace transform with two poles, exactly two poles at -1 and -3. Now let g2t be e power 2t xt and g omega converges. G omega Fourier transform converges. Determine whether gt is what type of signal. It's again a good conceptual question. Okay, so what is gt? gt is e raised to the power 2t into xt. right? So what should be the g of s? Laplace की बात करेंगे पहले. What is gs? Okay, now see, exponential term in the time domain. So this is related with the s shifting property. This is related with the s shift property, right? Okay, I can assume that xt has the Laplace transform xs, right? So for e power 2t xt, okay, the Laplace transform will be x of s minus 2. In the s shift property, sign goes opposite. If it is plus 2t here, it will be s minus 2 here. Opposite signs will be there. ठीक है जी? So x of s minus 2 is what I can write down. That is the gs. Acha, what is xs? Now what is xs? Okay, gt is a signal that has rational Laplace transform with two poles located at -1 and -3. Okay, so you know, numerator, there is no 0, so numerator can be 1 or it can be any number k, say for example, but there are two poles at -1 and -3, so this could be s plus 1, s plus 3. So what is s minus 2? Sorry, what is x of s minus 2? So when you replace s by s minus 2, the s minus 2 plus 1, it will become s minus 1, s minus 2 plus 3, it will become the s plus 1. So what are the poles of gs? Dear, what are the poles of gs? Gs is k by s minus 1, s plus 1, or you can also write this as k upon s square minus 1. And then what are the poles of this function? The poles of gs are plus and minus 1. Minus 1 and plus 1, these are the two poles for the gs. Correct? These are the two poles for gs. Also, they have given that g omega, the Fourier transform. Now, what is that condition, guys? Recall everybody. Given that g omega, that is the Fourier transform, omega domain mein chale gaye, that is in the omega domain, Fourier transform condition converges. What is the condition on ROC of a Laplace transform so that the Fourier transform is defined? Try to recall that point. Okay, and if you don't recall, that is what you will learn here also. No? With these questions, you will revise and collect important points. So the Fourier transform converges if the ROC of GS, if the ROC of the Laplace transform contains what? Contains the j omega imaginary axis. Contains the imaginary axis. Done hai ji? If the ROC contains the imaginary j omega axis. If the ROC contains the j omega axis, imaginary axis. ठीक है? That is what is g omega. Done hai ji? Done hai ji? Okay, that is what is g omega. Okay, now for the ROC to contain j omega axis, poles bhi mujhe pata hai. Okay, let's have a quick diagram. Okay, let's have this quick diagram. This is the sigma axis and j omega axis. Okay, and then the poles are at -1. So let me first draw a line through -1. Next pole is at the +1. So what should be the possible ROC? The possible ROCs are either to the right of the rightmost pole or either to the left of the leftmost pole. But if you take any of them, j omega axis, y axis will be skipped. So the third possible ROC here is take the ROC between the two poles. Okay, take the ROC between the two poles. So this can be a possible ROC so that j omega axis is included. Okay, that means ROC is like a strip. What I am able to get from here is ROC looks like a strip here. ROC looks like a strip, and when ROC is a strip, that is only possible if the signal GT is two-sided. Because for a two-sided signal, you get a strip type of ROC. Okay, for a two-sided signal, that is option number C, you get a strip type of ROC. Okay. I think GATE batches are already started, Anirudh. Okay. New batches will also be coming. For exact dates, you can look into the app only. Okay. But the batches, GATE batches already started. Acha, theek hai. The answer is C. Answer is C. Chalo. Next question. Okay, the waveform based question. Again, the next important waveform based question. Isko dekhte hain. Okay, what is the Laplace transform of GT? What is the Laplace transform of GT? It's going to be simple here because it is a rectangular pulse. Okay, and the rectangular pulse can be represented by difference of two unit step signal. It can be simply represented by the difference of two unit step signals. it can be represented simply by the difference of two unit step signal, such that one of the unit step can start with 3. Let's say another unit step starts with 5, right? And when you subtract, see, initially it is 0 minus 0, but only between 3 to 5. Only between 3 to 5 you have 1 minus 0, which will be 1. After the 5 it is 1 minus 1, that will be 0. Okay, so this particular waveform, I can say here, this particular waveform can be expressed as the difference of these two. So what is the first unit step? Shifted by 3 units, ut minus 3. Next one is ut minus 5. Next one is ut minus 5, right? So this is the value of the GT. That is u of t minus 3 minus u of t minus 5. Okay, that is the GT. So what is the GS? If this is the GT, what is the value of the GS? Right? No, Anirudh, gate batches are also there now. As far as I know, 90% I'm sure, separate gate batches are also started. Just check out clearly once, Anirudh. Okay. So now what is the Laplace transform? For ut it is 1 by s, but time shifting to e power minus 3s. For ut again it is 1 by s, but time shifting by 5. So 1 by s e power minus 5s. So this is e raised to the power minus 3s minus e raised to the power minus 5s whole divided by s. That takes me towards what it is, e power minus 3. So I think they have taken e power minus 3s common. Okay, so that is also okay. E power minus 3s divided by s, 1, and 3s is common, so 2s will be left. So e power minus 3s by s, 1 minus e power minus 2s, C could be the correct answer. C. Now that is what, B ko reverse kar sakte hai, but even C is matching, so B is not the correct answer then. Right, the C is coming up, they have taken e power minus 3s common, that is okay. Options are slightly rearranged, nothing much iconic. Done hai ji? Okay. Now this was only the difference of step signals. If I go to a triangular pulse, for the signal shown, what is the Laplace transform? Now this is a triangular pulse. This one is a triangular pulse. What is the Laplace transform here? What is the Laplace transform here? So how do you represent this triangular pulse? Okay, yeah. Let me just draw this waveform first of all, once again for you. What is that? It is between 1 se 2. And up to the amplitude of 1, correct? Up to the amplitude of 1, perfect. This is the xt given to you. Now, clearly the starting is a straight line, which is a ramp signal. And how much is the slope of that ramp signal? How much is the slope here? M. It is height upon base. So height goes to 1 unit. Base is also 1 se to 1 unit. So it is having a slope of 1. It is having the slope of 1. It is having the slope of 1. So starting is with ramp. So I can say that xt starts with ramp, that to unit ramp because unit slope. But where does the ramp starts from? Not at the origin, at t equal to 1. So shifted ramp, rt minus 1. But if it is only rt minus 1, if it is a shifted ramp, then, you know, once the linear relation, when the ramp started, it goes till infinity. But no, it doesn't go till infinity. There are changes, there are important changes at the point t equal to 2. And what are the important changes at the point t equal to 2? What are the important changes at the point t equal to 2? What are the important changes at the point t equal to 2? Let us highlight that. Important changes at the point t equal to 2. What are they? First of all, after this the signal drops to 0, and once it drops to 0, see, it is running on the x-axis. That means it has 0 slope. So at t equal to 2, right, there is a slope change. Okay, there is a slope change by minus 1. Earlier it was 1, now it becomes 0. So slope changes by minus 1. Also, there is a value change. There is an amplitude change. Amplitude was 1, suddenly it becomes 0. Amplitude at t equal to 2 reached 1, but suddenly, and sudden drop or sudden increase in amplitude can be represented by step signals. Okay, so there is an amplitude change Okay, that too by -1. मतलब amplitude drops. Okay, now slope change. Ramp signal. Amplitude change. Step signal. So which ramp signal will come? Whose slope is -1. So minus r. At what point ramp should come? T -2. The ramp should start at t equal to 2. Matlab it is right shifted rt -2. But also amplitude change by -1. Minus of ut will come because -1 is the amplitude. Minus of 2. The step signal is also required at t equal to 2. So 2 units right shifted step. Ut -2. Ut -2. Now we can complete the answer. Na? Okay, now we can complete the answer. So we have xt. So these waveform based questions are also important. We have it as rt -1 minus rt -2 minus ut -2. So what is excess? What is excess? Rt -1. Ramp 1 upon s square. So rt -1. Time shifting e power minus s will come. Okay. Minus rt -2. So 1 upon s square. Okay. E power -2s. Minus ut -2. 1 upon s. Unit step. T -2. So e power -2s. E power -2s. Okay, now options are there. Yeah, options are there. So we'll just have to see how the options are simplified. Okay, so we can first take it on the common denominator, that will be s square to e power minus s minus e power -2s, and that has to be multiplied with s, so s e power -2s. Now let's see what are the options matching up. Possibly, yeah, possibly I can take up no, plus to nahi hai, e power minus s by s square. Okay, minus of e power -2s upon s, -2s upon s. Yeah, b is actually matching up. Okay, as per the rearrangement of the option, what they have written, I'll write it like that only. E power minus s by s square minus of e power -2s upon s, upon a single s common. So 1 upon s will be left here, and this is +1. And this is +1. So option number B matches up completely. Option number B is matching up completely. Done hai? Option number B. The current, see, actually at t equal to 2, we need the slope change. Why we need the slope change? See, here the slope is 1 unit. Okay. But at this point, what is happening? The amplitude. At this point, what is happening? Number one, amplitude suddenly becomes 0. So there is an amplitude change, unit step signal is brought. But not only, see, if amplitude was the only change, then, okay, once I change the amplitude, after that, there will again be a line of 1 unit slope. Na? But is there a line of 1 unit slope? No. After that, the value is running on 0 axis. That is the x axis. That means if a value is running on the x axis, what is its slope? 0. So slope is also decreased by 1. Okay, to decrease the slope, we subtract the ramp signal, because when ramp signals are added, slopes are added. When ramp signals are subtracted, slopes are subtracted. Okay, so I need to have a ramp signal, okay, with the slope 1, and I subtracted. Okay, so minus r, so that the slope changes by 1. At what point I need the ramp? At what point I need the slope change? At t equal to 2. So ramp starting with t equal to 2 is rt minus 2. Acha guys, one more important thing for you, that, if you, still need all the details about ramp signals and the questions like this, waveform sketching, forget, Laplace to abhi humne kiya, but waveform sketchings with ramp signal, with step signals, okay, I have already taken some time back, you can search on the same channel, in the GATE fundamental classes only, I have taken up one complete class only on ramp signal, full detail, one complete class only on step signal in detail, one complete class only impulse signal in detail. Go and have a look into it if you want more, clarity about step, ramp and impulse type of signals. Okay, so that will give you more idea and more clarity, I think. Okay, chalo. Now, sometimes the question can also be system based from the Laplace transform. Sometimes the question can also be system based. Impulse response of a system is TUT. For an input UT minus 1, what is the output? For an input UT minus 1, what is the output? Now, impulse response of a system is given to you. What? The impulse response of a system has been mentioned to you. Okay. What is that impulse response? That is TUT, and that is nothing but the ramp signal, onto which you apply an input UT minus 1, shifted unit impulse. What is its output? Now, like the first question, Okay, output is convolution, but like the first question, I solved the convolution in Laplace domain because it is step convolution ramp. So what should be the output? Okay, let's say I call the output as yt. That is what is my question. And how do I calculate the output? The output yt is calculated as the input xt convolution with the impulse response. Convolution with the impulse response, and this is the input xt. Okay, convolution with the impulse response. Okay, okay. So what is yt? It is ut minus 1, that is the input. Convolution with the impulse response, which is rt. So let's take ys now. Let's directly take the Laplace, and convolution in time corresponds to multiplication in Laplace. Ut minus 1. Now ut has the Laplace 1 by s. Applying time shift property, I will get e power minus s multiplied by rt, which will have the Laplace transform of 1 by s square. Right. So overall it is e power minus s divided by s cube. E power the minus s is divided by s cube. So what should be the yt? 1 upon s cube. 1 upon s cube kahan se aata hai? Again recall t square ut having the Laplace transform 2 factorial by s power 2 plus 1 by s cube. So divide 2 on the left side, half t square ut. It will have the Laplace transform 1 by s cube. Okay, so 1 upon s cube is due to half t square ut. But I have e power minus s also, and because of the e power minus s, I should time shift by minus 1. So t minus 1, ut minus 1. So half t minus 1 whole square ut minus 1. Okay, it is actually slightly, very much, I can say, similar to the first question, but only thing is it is in terms of system, but ultimately it is a convolution based question to be dealt with Laplace transform. Otherwise, convolution of step and ramp in time domain, okay, will just make you crazy because it's a very lengthy process. It's a very lengthy process, right, dear students? Okay, ji. Moving ahead to the next then. Okay, moving ahead to the next question. What do we have in bank? Okay. Yeah, so taking you towards a simple gate 1 mark question. Consider a linear time invariant system whose input rt and output yt are related by the following differential equation: d2y by dt square plus 4yt is equal to 6rt. What are the poles of the system? Sometimes it can be very simple, just determining the poles here. Okay, so what I can do is just take the Laplace transform. Okay, first we'll calculate the transfer function. Okay, and for transfer function, okay, poles kahan se nikalenge? For poles, we need transfer function. We need what? We need the transfer function. And for transfer function, of course, we assume zero initial conditions, because transfer functions are only defined for initially relaxed system, zero initial condition ke saath. And because of the zero initial condition only, the Laplace transform for d2y by dt square will be s square ys. Okay, plus 4yt will have the Laplace transform 4ys is equal to 6rt, that is equal to 6 rs. Okay, now rt is not the ramp here, rt is the input name given to the input, it is not the unit ramp here. Okay, and yt is the output. Okay, so transfer function, okay, let's say t of s. The transfer function is what, guys? The ratio of output Laplace transform to the input Laplace transform, ys upon rs. So take ys common, divide by rs on the left side. So what is there on the right side? 6. And what will go from here? S square plus 4. What will go from the LHS? It is s square plus 4. And now tell me, what are the poles? There is no numerator, only denominator. I will make it as 0. S square plus 4 equal to 0. S square is minus 4, and under root of negative number will be imaginary roots plus minus j2. Plus minus j2. Plus minus j2. It is the option number D. It is the plus minus j2. Correct है जी? Just a sec. हाँ जी, ठीक है, चलो, let's move ahead then. Simple one only. Let's move ahead then. Yeah. A stable linear time invariant LTI system A stable linear time invariant LTI system, GATE 2 marks question hai, has the transfer function 1 upon s square plus s minus 6. To make the system causal, so it is already linear, I want to make it as causal. It needs to be cascaded with another LTI system having a transfer function h1s. What is the correct choice for h1s? Now it is already stable. Condition recall karenge. The system is already given to you as stable. Okay, but you need to make it as causal. What is the condition for a stable and causal system? What is the condition for the system to be both stable and causal is that all poles must lie in the LHP. Condition for stable and causal combined is all poles must lie in the left half plane. Okay. Now they are cascaded. When two systems are cascaded, the transfer functions are multiplied. Okay, this is H1, this is HS. Okay, so there is one system which is as HS. It is cascaded, that is connected in series with another system which is H1S. Okay, to give the final output. This is what is the cascade connection. This is what is actually the cascade connection. Okay, so what is the combined transfer function then? Okay, what is the combined overall transfer function of cascaded systems? For cascaded systems, the transfer function, suppose I call it as GS, it is going to be the multiplication of the two transfer functions, HS into H1S. Right, that is HS. HS is given to be 1 upon s square plus s minus 6 into H1S, and that is 1 upon s square plus s minus 6. So I can break this as s plus 3 s minus 2. I can factorize it, multiplied by h1s. Now I need all the poles in LHP. Right, this is a pole in RHP, and as per the required condition for the system, I need the poles in LHP, but s equal to 2 is a pole in RHP. Right, so h1s must be such that it must contain a 0. Right, it must have, right, a 0 at s equal to 2, so that there is s minus 2 in the numerator, so that there is s minus 2 in the denominator. They will cancel, and then there will not be any pole in the RHP. It can have any other term. Okay, but at least it must have a pole at s equal to 2, and of course it must not have any other, it should have a 0 at s equal to 2, and it should not have any other poles in RHP. Okay, so let's see the options. See, options are only having 0 wala terms. There is no pole. So where is the 0 I want? S equal to 2. Where is the 0 I want? S equal to 2. The term is s minus 2. The correct term is s minus 2. S minus 2 will give you the root as s equal to 2, right? Na? Equal to 2 the term. Okay, that is what it is. That is what it is. Correct answer is option number B. Done. Next case. For an interconnected system, again cascaded system shown in the figure, the combined causal impulse response. Combined causal impulse response hona chahiye wo. Okay, now two systems are connected in cascade again. The actual input is xt, the actual output is yt, and vt is some intermediate signal that is derived from the first system. It is again a cascade connection. Now how to deal with this? Let us understand this. Okay, let us calculate the transfer function, but then we'll convert into time domain. Now first let us consider the transfer function of this. Okay, converting into Laplace transform. Okay, so what is Laplace transform for v dot t? V dot is again the representation of derivative. So v dot, okay, s into vs plus vt will be vs is equal to xs. Right, so what is vs? I can write down vs common, and then s plus 1 will be left, which I divide on the right side to xs upon s plus 1. Now let us come here and again convert this into Laplace transform. Y dot, that is dy by dt, so Laplace transform sys plus yt, Laplace transform ys is equal to vt, Laplace transform vs. What is the value of vs? So yahan pe again I'll take ys common, and I'm left with s plus 1 is equal to vs, where vs is equal to xs upon s plus 1. Right. So what is the combined? What is the overall transfer function? See, maybe you can find individual transfer function and multiply, or I am just putting the result into second equation. So overall transfer function, which is the ratio of ys upon xs, and that is given by that is given by y upon x किया तो 1 upon s plus 1 whole square it will become 1 upon s plus 1 whole square. So what is the impulse response? Well, let's say this transfer function, just a second, let us say this transfer function is suppose gs. Okay, so what is the impulse response? gt. Transfer function is the Laplace transform of impulse response. Now what is gt? 1 upon s plus 1. We have seen all these results. ये किसका Laplace transform है? Right. For e power minus at ut, which is also in the option, Laplace transform is 1 upon s plus a. For t e power minus at ut, what is the Laplace transform? Derived by the t times property, derived by the s differentiation property. It is given by 1 upon s plus a whole square. Okay, so I am getting 1 upon s plus 1 whole square, so it should be t e power minus at with the a equal to 1. So t e power minus t ut is my answer. T e power minus ut is my answer. That is option number B. T e power minus ut is the answer. And it is right sided, that is why it is causal. Okay, it is causal. Causal system. Done है जी. That is what it is. चलो next one. A LTI continuous time system, okay, a linear time invariant continuous time system has the transfer function given to you. Okay, if ht convolution vt is delta t, then what is the value of vt? Fundamental है. If ht convolution vt, right, ht convolution vt is delta t, then what is the value for vt? Okay, now take it into the Laplace transform. First of all, convolution corresponds to multiplication. hs multiplied by vs should be equal to, right side also Laplace transform, na? What is the Laplace transform of delta t? It will be 1. It will be 1. Good evening all. It is going to be 1. So what is vs? First of all, I will find out vs, and that is 1 upon hs, right? And that is known as the inverse system. This is also the concept of inverse system. Okay, the transfer function is 1 upon vs, and that is the concept of inverse of a system. Now what is that 1 upon hs? hs is given to us. Okay, when you reciprocate it, iska reciprocal liya to s square plus 2s plus 4 divided by ss plus 1 divided by ss plus 1. Okay, divided by the ss plus 1. So what I can do is, first of all, little bit have a simplification. S square plus 2s plus 4 divided by s square plus s, and I can at least cancel it. Let me write down this 2s as s plus s. So some of the terms could get cancelled. Okay, so s square plus s now, s square plus s square plus s, this is cancelled. 1 plus the remaining term, s plus 4 upon s square plus s. Yeah, again let me write it as ss plus 1. We have to break that into the partial fraction then to get the answer. To get this the answer. Okay. S plus 4 upon s, s plus 1, इसको partial fraction में break करेंगे. Okay, so let's break this into partial fraction first of all. Okay, let's break this into partial fraction. S plus 4 upon s, s plus 1 can be split as a by s plus b by s plus 1 as per the partial fraction. Okay, as per the partial fraction. Okay, so what I'm going to now do is first, okay, multiply throughout by s, s plus 1. So s plus 4 will be equal to a, s plus 1 plus bs, right? To calculate the value of a, I will put s equal to 0. So 4 is equal to a into 1. So a का value आ गया 4. To calculate the value of b, I will put s plus 1 equal to 0. That is s equal to minus 1. तो यहाँ रखा minus 1, I get 3. And I am left with b into minus 1. So b is equal to minus 3. ठीक है. Now, this is the breakage of s plus 4 upon s, s plus 1. Let's take the complete vs. So the complete vs is equal to 1 plus this particular term, that is a का value 4 है, तो 1 plus 4 by s, and b is minus 3, तो minus 3 by s plus 1. That is the vs. What is the value of the vt? What is the value of the vt? So whose Laplace transform is 1? Delta t, unit impulse. Whose Laplace transform is 1 by s? Ut. whose Laplace transform is 1 upon s plus a e power minus at ut. E power minus at ut. Check out your answers then. Delta t plus 4 ut. Delta t ut is same as delta t only. Minus 3 e power minus t ut. Okay. So practically we should not write delta t ut because ut actual value is undefined. So properly if I want, okay, let me write this something like this. Whatever it is, C is the correct answer. That is what we have able to match up. Correct answer is definitely C here. Right. Next one. Input xt and output yt of an LTI system are related by the differential equation given to you. If the system is, now looking into this important condition, if the system is neither causal nor stable, that is one condition given to you. The system is neither causal nor stable, then what is the impulse response? Again, a differential equation has been given to you. Let me rewrite that. Y double dash t minus y dash t minus 6yt is equal to the xt, and first of all I will convert this into the Laplace domain, and I need the transfer function before I take the impulse response, and for transfer functions automatically we know zero initial condition will apply. So y double dash t means s square ys minus y dash t, that is s into ys, minus 6yt, that is sy 6ys, is equal to xt Laplace transform, that is equal to the xs. That is equal to the xs. Okay, so let me take out the ys common. S square minus s minus 6 is equal to the xs. So what is going to be the transfer function? Suppose I call it as gs, that is ratio of output by input Laplace transform, that is 1 upon s square minus s minus 6, and that is 1 upon, factorizing at this is minus 1, so I should have minus 3 and plus 2 in the factors. The s minus 3, s plus 2, minus s, minus 3 minus 2, minus 6, perfect. So this is 1 upon s minus 3 into s plus 2, this is the transfer function. Okay, but every transfer function has a ROC with it. Every transfer function, now here I have 1 upon s minus 3 and s plus 2, and it should be having a ROC with it. First of all, इसको पहले तो break कर लेते हैं हम, into partial fraction. So just easy to guess, I think this one, 1 upon s minus 3 minus 1 upon s plus 2. Let us see whether this works out, right? S plus 2 minus s minus 3, so s and s to cancel hoga, 2 minus 3, 5 will come, but here it is 1. By this fraction I am getting 5, so what I will do is I will take 1 by 5 outside, so that whenever 5 comes, divide by 5 is ready. Okay, ye to ho gaya. Now what are the poles of this? The poles are s equal to plus 3 and minus 2. Okay, so what is the ROC? There can be any possible ROC. Right of the largest root, that is right of 3, left of minus 2, or between 3 and minus 2. Okay, but I want the system to be neither causal nor stable. Okay, neither causal nor stable. So kya karenge na? See, what are the possible ROCs? Let me write down. What are the possible ROCs? Number 1, right of the largest root. So let me write down the roots in increasing. Poles are minus 2 and plus 3. First ROC is sigma greater than 3, right of the largest. Second, left of the smallest pole, left of the leftmost pole, so sigma less than minus 2. And third case, it is between the two poles. That is what is the possible ROCs, na? As per the two poles. So it can be between minus 2 and plus 3. These are the possible ROCs now. For the case number 1, ROC right-sided. Right-sided ROC is for a causal. System. So this will make the system causal. But system will not be stable. So causal system requires, let me write down here, causal system requires a right-sided ROC. A right-sided ROC. A stable system requires what? Stable system requires a ROC which contains the j omega axis, right? Requires a ROC which contains what? Which contains j omega axis. J omega axis matlab sigma should be 0. On the y-axis x, or that is sigma, should be 0. So here the system is causal, okay, but unstable. Because sigma cannot be 0. It is greater than 3, so sigma equal to 0 is not included. But what I want in the question is system neither causal nor stable. Neither causal nor stable. Okay. Have a look into the third case. -2 se 3. The system, the ROC is not right-sided. This is non-causal. Okay. But between -2 to 3, 0 will come up. Sigma equal to 0 means j omega axis. So this ROC is including the j omega axis, so this will be a stable system. Okay, let us come to the second one. Sigma less than -2, left-sided, anti-causal. Okay, anti-causal, left-sided, anti-causal, and let me just write it as non-causal only right now. Causal to nahi hai na, at least. Sigma is less than -2, so sigma can't be 0. It is less than -2, right? So it is unstable also. It is unstable also. So what is the ROC to be chosen? What is the ROC to be chosen is the second case ROC. Okay. What is the ROC to be chosen is the second case ROC. Is the second case ROC. Just a second. What is the ROC to be chosen is the second case ROC. Right. So I'll now write down once again the transfer function GS. After breaking into partial fraction, I got it as 1 by 5, 1 upon s minus 3, minus 1 upon s plus 2, minus 1 upon s plus 2 with the ROC sigma less than -2. Acha, if sigma is less than -2, automatically it is much less than 3. It is much less than 3. So what is the formula I will apply? So what is the GT, impulse response? 1 by 5, right? What is the formula you are going to apply here? Sigma less than -a, right? So the formula for minus e power minus at u minus t, left-sided signal. This has the Laplace transform 1 upon s plus a with the ROC sigma less than -a. With the ROC sigma less than -a. तो यहाँ पे आएगा minus of e power 3t, a का वैल्यू -3 है, u minus t, right? Minus of minus e power -2t. Again the same formula applying with a equal to 2 u of minus t. ठीक है? So the answer is, in what form it is arranged? Yeah. So let me just open up the bracket. Minus 1 by 5 e power 3t u minus t plus minus हो गया plus 1 by 5 e power minus 2t u minus t. That is what it is. Okay. Minus 1 by 5 e power 3t u minus t plus 1 by 5 e power minus 2t u minus t. Option number B is what is matching up completely. Option number B. ठीक है जी? Option number B is the very correct answer. Option number B is the very correct answer. Yeah. So guys, be ready. Sunday at 11 p.m. an important guidance sessions. If you are dreaming to be a single digit rank, a top rank holder in the GATE examination, what are the 1, 2, 3, 4, 5 success? Okay. 5 mantras of success so that you ensure you get your victory in the GATE examination. On the same YouTube channel, join me live Sunday at 11 a.m. Right, and these are the different series already running up. GATE fundamentals Monday to Friday, okay, like I have taken today. NILIT crash course for computer science and EC going on MWF Sunday. The ISRO series for electrical is going on Monday to Saturday. Coffee with concept and conceptual recorded videos, okay, is coming up twice a week. The learn with fun, the practical based understanding of the concept, very important. This comes up every Sunday at 7 p.m. and the BYJU'S Exam Prep student success saga continues in GATE with 13 ranks under 10, 107 ranks under 100 and 62 students securing rank under 50. That's it from my side. I hope you have enjoyed the question practice session. Very important and conceptual question of Laplace transform we have discussed. Of course, you need to have more practice from your side that you can do now because you have learned concepts and you have got good range of practice. Okay. See you in the next class. Bye bye. Thank you. Stay safe and take care.